What's poppin', dogs? Mr. Allen here, solving some compound inequalities and then graphing those solutions on number lines in this video. So let's try the first one here. I got 3x minus 2 is greater than or equal to 10, or negative 2x is greater than 6. So it's kind of just like having two problems in one here, so we'll solve it just like we normally would an inequality, which is exactly like we'd solve an equation except for a couple different rules. So what am I going to do first here? Let's add 2 to both sides, and I'll get 3x is greater than or equal to 12. Now, recap here, what is different when solving inequalities as opposed to equations? Well, in this step here, if I divide by a negative number, then I would flip that inequality. Am I dividing by a negative number? Absolutely not, right? We got x is greater than or equal to 4. So that's one of my solutions here, but let's get the other one and then we'll graph it all at once. Here, I need to divide by negative 2. Ooh, what did I just say? I said if I divide by a negative number, I got to flip my inequality. So I'm going to have x is less than negative 3. 6 divided by negative 2 is negative 3, and I flip that inequality. So now I have these two here that are parts of my solution. I'm going to write it as a full statement here once I graph it on my number line. I think it will look really good if I graph it first and then write it. It'll make a little more sense. So I have x is less than negative 3. When it's strictly less than 1, 2, 3, negative 3, I'm going to have an open circle, and it actually, if I have the x on the left side here, it will point in the direction that I need to go. So if I write my x first, super helpful when graphing these things, it points in the direction that I need to go. Same goes with this guy, 1, 2, 3, 4. But this time it's equal to, greater than or equal to, it's a solid circle, and I'm going to go up and to the right. Now, different teachers like to graph these things differently. Some will just say make a thick line on here so I can see it. Some will do like a scribble kind of a thing so you can see it. I like to go up and over so it's very, very clear. It also allows me to make sure that my open or closed circles are also very clear. Now we do need to write this full solution here, and I did want to wait for the graph because I think that would be helpful in writing it. I'm going to first write my x is less than negative 3, and then because there's this gap here, and it also started out as an or statement, I'm going to have or x is greater than or equal to positive 4. So this is my written solution here, and then my graphed solution. They show the solution in different, different ways. Nice and visual here with the graph, and then I've got some cool inequalities that everybody seems to forget which direction they go. So please pay close attention to that. This is x is less than negative 3. This is x is greater than positive 4, okay? I know it's a challenge to remember what direction these things go. It does take some practice and just reminding yourself as you do it, okay? Next one over here. I'm gonna go orange for this one. So new compound inequality, different than this one. This was just kind of like two separate ones, right, that are together and then an or statement. This is an and statement. It reads negative 13 is less than 2x plus 1 and less than 9, okay? So how do we do this? Well, it's kind of like two problems in one, but actually what you do is you just deal with three pieces at once. So I'm going to have minus 1 here to get rid of that 1. Well, I got to do it to both sides of the equation, right? But in this case, I've got a few different sides here of my inequality, okay? So we got to subtract 1 from everything, each component here, each part of my inequality, I have to subtract 1. So I get negative 14. I have less than 2x less than 8. Now what do? Well, I'm going to divide by 2 on everything, all three parts. Now over here I have negative 14 divided by positive 2. Since I'm dividing by a positive number, nothing flips. If I'm dividing by a negative number like I did here, then the inequality flips. I have a negative 14 getting divided by a positive number, so nothing changes because what I'm dividing by is positive. Okay, I think I said that enough. Here I'm going to have those cancel. I'm left with x, and then over here I'm going to have positive 4. So there we go. We've got it. It's solved. It's done. This is our final answer. This is exactly how I'd write it. X is greater than negative 7, and it's less than 4. That's how you would read it. This is an and statement. So now I got to plot them. Let's see here. Negative 7. 1, 2, 3, 4, 5, 6. Let's add another one over here. Negative 7. That is an open circle because it is strictly greater, x is strictly greater than it, so it's going to go this way. And then I have x is less than 4, 1, 2, 3, 4, also an open circle, and x is less than that. and they get joined in the middle there, okay? So stays between, it doesn't go past. If you have an or statement where they're like this and they overlap, it actually has infinite solutions. I'll show that in another video, but for this one, it's just right between the -7 and the 4, and I kind of like how this looks and this looks. The x is between the -7 and the +4. Here, my shaded graph, my line that I have, my scribbles, whatever you do, is between those two numbers. So again, visually make that connection so you understand what in the heck is going on, and you can get it right on your quiz or your test. All right, dogs. All right, dogs. That was a nice voice crack. We'll leave it in there. That's hilarious. Anyways, thanks for watching, you guys. If you have any comments, let me know, or if you have any questions, let me know in the comments. I got to end this thing. Have a great day, guys, and, of course, stay positive, dogs.